There you go. My background is the forensic side of fires and explosions. And over 20 years ago, I started investigating both fires and explosions in grain facilities. So I've done it for a while. I'm not saying I know everything. I'm still learning. This is a daily process of learning new information. Over that period of time, what I have seen is I've seen the facilities get bigger and bigger. I've seen farm sites, which is what I was in Ohio on recently, become bigger and bigger and more involved. They're starting to store more and more grain, and perhaps that's always been for the last 20 years. I don't know. I have not worked a lot of cases in the state of Ohio, but I have worked a couple recently. Basically, why I was out there was a gentleman farmer experienced a fire in a facility. And when I got there and started talking to him, I realized that he made some, I won't call them errors because he did what he thought he could do to stop the spread of the fire. But what he actually did is made things worse. And so I was hoping to tell people about that and talk to you guys right now about that. This gentleman is running a tower dryer, which is a circular dryer that's, I don't know if it's 100 feet tall on this particular site. I don't think it is. It's a shorter one. And he was out in the field and he was running it on an automatic mode, which can be problematic because they just have some issues. You're not tending it, so you can't react quickly enough. And when he came back, he saw some smoke and discovered a fire. And then he did what most people would do. He simply opened up the slides so that he can drain the grain from the columns. And basically what happens when you do that is you have a superheated space that's already experiencing an overheat condition. And he allowed the one thing that fire really needed to take off into the system. He allowed air into it. And once you start draining that grain and allow the top to start venting out because there's a gap at the top of the columns, then that grain is able to evolve other areas of grain that aren't quite ready to burn yet. And he almost lost a bin, which was in very close proximity to this grain dryer. So basically, the short version here is that if you can figure out a way, and he had this capability, but he didn't realize that would have been a better choice. If you can figure out a way to keep running wet grain into the top of the dryer, which he did not do, he shut off all of his equipment, opened the slides, let the grain drop down in the columns, and that essentially generated the perfect chimney. And so that fire was just shooting out like a Roman candle at the top, and they got in over their head on the bottom and they couldn't really put the fire out, and they ended up losing the entire dryer. I'm not saying that I have all of the answers because I don't. What I am saying that I've seen numerous farmers and other facilities and that really understand this system, they start to realize that if you keep pushing wet grain in, you do two things. One, you don't give it that air gap at the top, so you're not drawing in a lot of new uncontrolled air through the bottom, because that's what happens. Once you make that chimney, the fire extends out the top and it just draws in all the air it needs through the bottom, and you're off to the races. In this scenario, the best thing I believe you can do is continue to fill the hopper with wet grain. And not all systems are capable of doing this. So in a lot of times, I think you're going to find out that the way that they've wired the leg to the movement of grain precludes them from being able to do what I believe that is the best bet based on what I know. And if you can continue to run grain and fill that hopper and have an overflow so that, because the hopper can't, on the top of the dryer, cannot take all of the grain you're going to give it, it has to overflow back into another bin. The one thing you don't want to do is take burning grain and run it into another bin or run it into a leg. Then you have a completely different scenario that becomes very dangerous. And if people are standing by and there is a dusty layer of grain inside a leg, you could have an explosion, and usually that is fairly close to where these dryers are. So I don't know if there are any questions. I'm more than happy to talk about specifics or other things with people, but the area that I went out there on was specifically grain dryers. So are there any questions?
Yeah, any questions for Peter so far? So feel free to unmute yourself, or if you're not familiar with Zoom, there's also the chat option. I can put it right here in the chat box.
What is a chat box?
Oh, it's down at the bottom. So you'll see a little chat box, and you can type and ask and answer questions along the way.
Oh, I like that little option.
Yeah. So Peter, I have a question while some other folks are trying to figure out their Zoom options. So if you notice that you have a grain dryer fire and it's on automatic mode, what should be the first thing you do?
Well, normally I would try and locate what I call the hot spot. And if you notice you have a grain dryer fire, a couple of things happen. Either the grain dryer itself is tripped out over temp, or you see something abnormal. Maybe you see a glow in one of the columns. The outside of these grain dryers, the column style dryers, the tower dryers, have a series of rings around the top on the outside of the dryer. And those rings are an indication of temperature inside that dryer, or the airflow that's coming out. There's also an internal temperature that is kind of a plenum temperature. And so if the plenum temperature gets too hot, then that could potentially trip it out as well. So if you're not standing there, you may not notice the onset of that fire. And that's why I like to see the majority. I believe that these grain dryers should be operated and manned full time. And that is very unlikely in a farming setting. They all believe that, well, it's got an automatic mode and I can just walk away from it. But the truth of the matter is the automatic mode is something that has to be calibrated all the time, and you have to keep updating that calibration. If you don't, your percentage of grain that you see coming through may become drier than you really want and be easier to get involved in a fire. So I'm not sure if I answered your question, but completely, but I think what I've heard over time is what most people see is they see some smoke that isn't right. And then when they start looking at the grain dryer, and there's several types, they may start to see some glowing embers or something that tells them that isn't right, some red discolor or some areas of red, which is just basically glowing combustion. And if you can identify where that is in a column dryer, this becomes quite easy. That's the column you want to go after first, and you want to drain that, but you don't want to drain that until you can put fresh, wet grain on top. There's two reasons you want to do that. One is there's a higher moisture content in the grain. So the grain itself is harder to get involved. It generates steam. You have to wick out that moisture before you can get that grain to go. It's colder because it's not involved in the fire. So you do basically two things. You cool the fuel load, you add moisture, and actually you do three things, and you deplete the incoming oxygen that would have been drawn into the bottom freely into the bottom of a column dryer. And I believe that you'll find that that's a very successful way to combat a fire in a column dryer.
Thanks, Peter. Other questions for Peter so far?
Okay, so please just feel free to cut in and ask questions. I've got a lot of knowledge. Sometimes it's hard to download it all because I don't know what you guys are thinking, but I will try and just kind of add on to this a little bit. Well, first of all, does that make sense to people that we're trying to cut off the airflow, keep the grain cool, and drain that area of where we see a hot spot? And so if we see a hot spot in one single column, we'll drain that column. And then as we start getting grain to go into that column, we probably want to slide open the other columns near it, but not all of them at once. The incident where the gentleman thought he was doing the right thing and getting the fuel load, I mean, it's a very good way to think. Get the fuel load out of the dryer and your fire is over. But unfortunately, it takes a long time to get the fuel load out of that dryer. And by the time you get it out, well, basically what happens is the way that they make these dryers nowadays, you don't have enough room around the base of the dryer to drain the entire dryer, especially when you get into the bigger dryers. This particular one was a smaller capacity. I don't remember if it was 12 or 1800 bushel per hour style dryer, but he just didn't have enough room. And here's why. The design of the dryers when they put them on the sites is often in a crowded area. And so you can't walk up to the dryer or drive up to the dryer with a skid steer and pull the grain away. So there's some areas of that dryer that you're going to fight to get the grain out of those columns. I don't know how long it takes to empty a dryer completely because there are so many different style dryers that it would depend on that dryer and the flow of the information that you have. 1 second, please, and I'm sorry about this. That it just takes, it depends on a lot of things. The holes in the bottom of the columns are quite small. You can put your fist in it, but you're not going to put a soccer ball in it. So if that makes sense, then you can realize that the column width, let's just say it's 2 feet in width. If you drop down and try and exit the dryer in a 6-inch or 8-inch hole, there's not a lot of space to get that grain out. So,
Peter, I just did have a question that popped up.
Okay.
So
I don't
you
see a
mentioned
question.
earlier automatic mode is not as fire safe as the manual being by the grain dryer the whole time. But we all know farmers, and a lot of them are one-man operations. They need to sleep at some point, right? So is there any technology out there that is useful? I know that there's some monitors that are on your phone. Is there any sort of technology, maybe not specific products, but technology that you'd recommend to farmers add to their grain dryers to make it easier to detect those problems before they pop up?
So here's the problem with that. And I believe there is technologies that will tell you the dryer is kicked out, or it's given you a over temp or a fan off or an overheat or some sort of a warning. The problem with that is, where are you when that happens? Because you're in a critical time right now. So if you're out in the field, which is where this gentleman was, he was out in the field when this fire occurred. Is that a safety net? I mean, if there's somebody in a building right there, you can get on the phone and say, hey, can you go check the dryer? There's something wrong. That's a possibility. But when you're out combining a field or cleaning up a field or doing whatever you're doing out in the field, it's going to take you a while to get back into the farm site to determine what's going on. There are 2 typical modes that a dryer is operated in. First is automatic mode. And a lot of people really don't use automatic mode. They use a manual mode, which has got its own set of problems. I don't know why it is, but a lot of farmers tend to they set the dryer up. They think they have consistent moisture grain going into the dryer. And let's just say your grain's 20%. Well, if your grain is 20% going in and it's consistently at 20%, that's a good thing. But the problem is when you pull grain from the field, it's not all 20%. Some may be 25, some may be 15. So that's a big swing that you're dealing with. And if you're trying to dry to a 13 or 14%, or maybe even 15% moisture, and you think you're putting in 20 or 21%, but you're actually putting in 17%, the number of points that you're actually taking off of that grain is not as much, but your dryer is set up for the reduction from 21% to whatever your target is. I don't know what you guys use as a target. Some people do 15, 15 and a half. Some people do 13. What are you guys typically seeing out there? If you know.
Usually
Okay.
15.
16?
15.
15, yeah.
Yeah.
So, and back in the day, I saw more people pushing to 15%. But the biggest issue why we have these fires is because we're not monitoring the equipment as diligently as we could. So it's very hard to monitor grain flow in a column of grain. And, people tell you, well, I went out there and I could see that the grain is kind of, cascading down in each one of the columns, that it's just kind of moving down. But what they don't see is halfway up or 2/3 up the hot section, there's some structure inside. I don't know if you guys use turners in your grain where they take the grain from the inside of the column and transfer it to the outside. Do you guys ever see that? And then they take the grain from the outside of the column and transfer it to the inside just to give those kernels a break so that we don't have damaged grain.
I haven't
ever see that out there?
I haven't necessarily seen that, but it doesn't mean that it's not here. So I'm just not too familiar.
What I'm trying to say is we can see at some points if we walk around the bottom of the tower dryer or another style dryer that grain is moving, but we can't see everywhere. And I've concentrated on tower dryers because it's one of the easier ones to see grain moving, and I seem to work more tower dryer fires than others, but it's not the only style dryer out there. And what I end up seeing is when I start to investigate, I see foreign material, leafy, stocky material that gets drawn into the dryer by accident, and it gets plugged up or stuck into the areas inside the column, and it slows down or stops the flow of grain in certain areas of a column. Well, the second you stop that, then you're going to get an overheated situation that is going to continue to heat up, and you'll never get the break of the cool down section. And over time, that grain will start a glowing combustion process, and it doesn't usually end very well unless you can spot it very early. And so that is the observation that I see. How do we get that stocky, leafy material in there? Well, there's a lot of ways. If we run a bin out and we run our let's say we have a wet bin that's 5,000 bushel and we're running this thing for 10 hours and we're trying to keep that full so that we can dry that grain. And so that means we got to go out into the field and keep bringing grain back. What ends up happening is if we go bin empty, all of the leafy, heavier material is kind of sitting there riding on the top of the grain as it's flowing down the bin. And we get this load or wad of leafy, broady style material with stalks and other things in it. and that goes into the dryer. That's a pretty bad situation. The grain dryer is intended to flow all of the hot air through the grain. The grain is a screen. Well, if the mesh of the screen is much bigger, the hot air flows through that area much faster. When that happens, we overheat that grain. And it tends to be a problem because, especially when we're not in the field and don't even know it, it tends to be a problem because that's where these fires typically will start. All fires are not started by what I'm talking about, but I see more and more of them as we get bigger and bigger fields and we try and do more tasks when we're not sitting there on the farm site. So perhaps some people who are here have heard of other scenarios where the fires have started, maybe a piece of equipment that's not operating correctly, or drawing in bad grain or hot grain into a dryer. I don't believe that that is such a scenario where you're drawing in out of condition grain that gets in there into a dryer that becomes a problem. What I do believe is that there were years when we were getting really wet grain. We had immature kernels that were 30%, and we're trying to dry the grain so that we can get that moisture out. Well, that takes longer time in the dryer. And with the immature kernel, the issue really becomes slightly different because now it takes longer time, but the kernel is not as robust as normal. And so we're drying that out quicker. And now all of a sudden we have a lighter kernel at the end of the day, which is easier to ignite. That's kind of like lighting a piece of rice paper compared to a piece of cardboard. So those scenarios exist. I see them out there, but that's in times when we have very immature grain that we're trying to dry. From a firefighter perspective, they're not going to know what the capabilities of a farmer's operation are. So we kind of have to educate the farmer to try and monitor these equipments, the equipment that they're using, especially the heat producing equipment like a grain dryer, on a continual basis. And that's very difficult. But the other thing that I believe we need to do is we need to understand that when a bin goes empty, the product is different, because if you look in a bin, all of that light, the heaviest thing in a bin is always going to go out first. Excuse me, I have a bit of a crazy schedule today. The heaviest product, which should be the kernel of grain, is going to go out. You drop a hammer in there, it's coming out real quick. You drop a person in a bin, it's going to come out really, it's going to be a bad day. But there's a big difference between the leafy material, the stalks, and the kernel of grain. That grain is going to come out first. And if you go bin empty, then you're going to draw that plug of stuff in there, and it's going to create havoc. And it could create havoc in a lot of ways. So the best thing we can do is not allow bin empty scenarios. Try and make sure that we have a very consistent grain flow. We all want to say, hey, it's about 20%. And when I start looking at the spreads of the scale tickets that they're producing and the moisture content, I go, well, 20% we think it is, but here's one at 27 and here's one at 17. Those are big numbers. And when you have a grain cart full of grain, which are getting bigger and bigger nowadays, I've seen grain carts almost, I don't know, they make them big, or a semi load, or a field that is much better than other fields and you think it's all 20%, that swing in moisture is tough. And when in manual mode, it's a problem. But in automatic mode, the thinking is, oh, well, it's automatic mode. It's going to just operate on its own. And the reality is that if you're not calibrating that moisture output appropriately and frequently, that it's really not in automatic mode. It's just kind of moving along. The sensors, the grain moisture sensors in the bottom of the dryers, or even in the top, are only as good as the calibration and the maintenance on them. So,
Peter, I had a question. You had mentioned firefighters when they show up.
yes.
So we have a mix of farmers and firefighters and a couple of both farmer firefighters. So if you're the farmer, you don't create air pockets for the fire to go up, you dump wet grain on top. But do you have any suggestions or recommendations for firefighters who show up on scene, how to tackle that? I know every scenarios can be different, but is there some general guidelines you can suggest?
You know, the history of firefighting is what? We got a fire, we got water, we're going to put water on the fire. Well, that's not necessarily the way to fight a grain dryer fire. You may need water. I'm not saying you don't need water, but what you really need to do is think in the, how do you cool that fuel load? Because you're not going to get it out quick enough. And so if they understand that the best thing they can do is, you see, it's a difficult thing for a firefighter because they're not going to know the farmer's capabilities, but they can start asking questions of the farmer and asking if there's a way to continue keeping that upper hopper full and allow the grain to go through there. That's going to kind of squelch that fire or quench it in a manner that they're not used to. You know, they all want to ventilate a fire to get the heat out, but the second they drop the grain, which is in their process, their way of thinking is a ventilation process, they're actually creating the perfect chimney. And so you get the oxygen being flown in, you know, drawn in aggressively at the bottom, and you get a Roman candle at the top. You're not going to get away from that situation. You don't have enough water. So they really need to kind of, if they show up on a scene and there is in fact they can find a hot spot in that dryer, they need to figure out how to drain that column and keep grain going into the hopper. And that will give them the best bang for their buck. I have seen one other way that, I don't know, this is probably 15 years ago. Somebody put in a brand new dryer and they had a dryer fire and they drained that dryer and the dryer actually burned so hot it tipped over and imploded basically on itself, and then it basically tipped over. So that particular individual was upset about it. He had just bought this dryer, spent a lot of money. I don't know what it cost him, but it was a big dryer. So he developed a system where he put a standpipe on the bottom of the dryer that went up through the plenum and the hot air section. And so when the fire department shows up, they can just hook onto this and deplete the heat by adding moisture inside the dryer. I thought it was a very interesting approach. And you know, if people have that ability, that may be something that we can think about as we go forward. I don't know of a commercial system like that. I just know of some homemade systems where they physically crush the end of a pipe, put some small holes in it, a 2-inch pipe. They slide that pipe up through the hot air section of the dryer, and they have a standpipe off in a little distance so the firefighters can get to it. And then hopefully they have enough pressure to get to the top of the dryer. You know, but a firefighter isn't really going to know that. I think the biggest thing they need to understand is when they drain a column, are they going to get that heat out or are they going to create the ability to burn more? And I believe that they're going to find quickly, if they just drain columns, you're just going to, if you have a hot enough interior to the dryer, it is going to continue to burn. You're not going to get away from that. So the firefighter side of this is very difficult unless they're farmers. And a lot of them may have some additional information. I think the real issue starts at the farmer. Gets them to understand, if we can keep that full and not just drain these columns, we'll be better off. Sometimes you can have a very small fire in a dryer. You drain 1 or 2 or 3 columns and you're done. And the cleanup is much, is not as intensive. You don't have as much grain waste, because what do you do with smoked out grain? I don't think a lot of cows like it, and you're not going to put it in your cereal. So.
And Peter, we've been talking primarily about corn, correct?
Yeah, but there are other things.
So are there any differences between, say, small grains and soybeans and corn that farmers and firefighters should be aware of in terms of how they act or concerns?
Well, so most of the fires that I deal with are one of 2 things, either corn with 3 things, sometimes wheat, believe it or not, but corn or soybean. Soybean is something you don't want to put water on. A soybean swells up, and once you put water on that, you've got nothing but problems. So the small grains, what kind of grains do they use in Ohio? Like Milo, or what are we dealing with?
So run across the board. So wheat, barley. I don't think oats get dried that often just because it comes off in the summertime, but yeah, it's a variety of different crops. But
yeah, so I'm going to be honest with you and tell you I know less about those small grains. I think if there's not as much, I just don't see them dried that often. That's the problem. Soybeans, or excuse me, sunflowers. Do you deal with sunflower at all? No,
we don't deal much with sunflower.
I would say the smaller the grain, the easier it is to ignite. Maybe the lower the temperature you have to do it, or the quicker the pass time if you're going to use a relatively high temperature. I don't know what the methodology is of the farmers in Ohio and what kind of temperatures they want to run their dryers at. They all want to get as much work done as possible, and the obvious thought is, hey, higher temperature, faster pass times, we're going to be done sooner. But that's not always the case. Sometimes it just takes time to drive out that moisture. The other thing, and maybe you guys don't deal with this that much, is, if you have a lot of grain and it all of a sudden gets cold and you continue to try and dry that changes the operation of that dryer in a way that it takes more time to do what you think it is. And the reason is because a dryer can only produce so much temperature rise, and that delta between ambient temperature and temperature rise is all it can do at so many BTUs. And so if that's 30, 50, or 300 degrees, whatever it is, when it gets much, much colder, and I've seen people try and dry at 20 below, and it's just never really comes out good, because they leave wet grain in overnight, it freezes, then they have problems, and they don't ever really get the temperature, so their drying time over a period of time is much longer. And so either they run that 24/7 until they're done, and they use a lot of propane or natural gas, which seems to be a very high, I don't know what's happened out there with natural gas, but that's gotten quite high here, maybe 2.5 times per therm. But so I do see that. Do you guys have those temperatures out there? Does it get that cold? 20 below?
Not very often, no. If we get down to 0, that's a pretty low temperature, but we don't get down to the negatives very often.
Okay, 0 Fahrenheit. And so even at 0 Fahrenheit, that's tough. At 20 degrees Fahrenheit, it's tough because your delta is not as great as it is in the summer. You know, the difference between 0 and 80 is huge, 60 degrees. So you're essentially trying to produce either more heat and you can't combat that 60 degrees, or what people end up doing is slowing the pastime down. So they slow the unload rate of the dryer so that the grain is in the dryer longer. And if you're not watching it, then all the things I said before, and so many of these dryer fires kind of float around a bin empty or a plug of stuff getting in there. I don't think I really explained, and I know you asked about firefighters earlier, but I don't think I really explained something about if you get a plug of material in there, where does all the heat go inside that dryer? Well, the dryer is trying to produce pressure. And that pressure moves through the grain, so it dries it, and it tries to do it evenly. Well, unfortunately, if you have an area where the mesh of the grain or the material that you're trying to flow through is not as dense, what happens to the pressure? It all goes through there. So now that dryer says, hey, I'm losing pressure, I'm not getting as much heat because all my heat's going through an area. And so it may want to ramp up the temperature, not knowing that the real issue is that we basically have a sieve in our grain column. The grain is not dense in one area. And so now we're generating all that heat through that area, and we get back into that glowing combustion. If you can catch these fires early, they're very small. But that's another reason that we should try and kind of monitor them more frequently. Again, from the firefighter perspective, typically they want to put a lot of water on a fire because that's how they cool them. And you can put a fire out like that, but at the cost of the dryer will be consumed by that point. If you looked at the one that I went out to, it was a completely burned out dryer, and the actual bottom floor of the garner was imploding, and it got so hot that it's kind of melting, and was kind of not melting, but changing shape. It had no more structure in it, and it started to collapse into the dryer, so much that I didn't even go up to the top internally because I felt I may be at risk. That dryer is still there, and perhaps it still will be there when I come out later next month, I believe it is.
Peter, you mentioned monitoring. We didn't have a question come in. So what new technology is available for early fire detection? We talked about the monitors where grain dryers are kicking on and off, but are there temperature sensors or thermal cameras or some other technology that is coming out or that you're aware of that can assist in the early fire detection versus monitoring the function of the grain dryer?
That is a great question. I wish there was something that would be the cure-all to these fires, but I don't know if the gentleman who asked that question or person who asked that question has some ideas of that. I have often thought of developing some sort of temp sensor that's inside a column. And here is how I thought about it. I thought, well, if I just monitor every grain flow, I could either do temp sensor or movement flow, because if the grain is not moving, we have a problem. And if the temperature gets too high, we have a problem. But then I go back to, okay, I know that the moisture sensors they're plagued with problems. And now we're talking about putting in a whole array of additional sensors inside that dryer that will likely need maintenance and other issues. A thermal camera is expensive. If you had a thermal camera, and a lot of firefighters do, They're a very good way to determine where those hot spots are if you have the right thermal camera. So that's a really nice piece of equipment. I do not know any new technology that is foolproof. And so I think it's something that may come out over time, but I think there are so many difficulties with it. Nobody's jumping in to get that technology out there because they're having problems with the systems that they're using. If you put a grain flow movement in a column of grain and you have 15 or 20 columns of grain, where do you put it? Do you put it at the top? Do you put it in the middle? Do you put it at the bottom? If you put it at the bottom and you have a plug in that column, what happens to the grain? You're still pulling the same amount of grain off the bottom by a carousel or a metering roll or something, but you basically generate the hourglass effect. So the grain that's on the top is moving down at a rate. When you get to the plug, it just moves faster around there. And then when you get to the bottom, it's normal. So if we're doing it on grain movement, how do we deal with that if we really can't deal with the entire column? I will tell you that I have seen some people very closely monitor the outflow of grain. And let's just say, I don't know what the temperatures are. Are there farmers out there that are looking for target temperatures on the outflow of grain? Are there any of those on this call at all? If so, what is that temperature? I have seen a group of people that utilize a temperature sensor system that is really no more than a thermometer. And what they're doing is it's a very sensitive thermometer. They're monitoring the temperature, the outflow of the grain at the cool down area. And the second that they see grain, that is, let's say their target temperature is 85 degrees, and they get it set up to run at 85 degrees. The second they start seeing grain that's creeping up at 87 degrees, 89 degrees, they know they have a problem and they know that they need to adjust. So if they're on site, they can go outside and see if the problem is within some sort of detectable flow issue in that column dryer, or do they need to increase the pass rate or slow it down or lower the temperature? Those are the scenarios that you can deal with in a dryer. And so if they can do that, that's a good thing. But I really don't see I don't see a successful early fire detection system in these grain dryers other than you being there. If you get a shut off, don't go and try and start that dryer, because that's what this gentleman did. He actually did try and start that dryer a couple of times because his dryer did shut off. So I believe, if I recall right, on this particular fire that I was in Ohio, he got at some point he got a warning, or he showed up and he realized, hey, the dryer's off. I'm gonna try and start it. Put air through it, cool it down. That's not what you do on a dryer fire. You're feeding that fire. So I do believe he attempted to start it and allowed some airflow in there. So again, early technologies or new technologies I'm not familiar with. Is anybody else on this call familiar with them?
If so, feel free to unmute or use the chat box to join in or add any comments.
I would be very interested in that because I think I said at the very beginning of this call, I'm still learning. And I think together we can all learn together. You know, the second you think you know everything in this business, yeah, I think you're going backwards at that point. So we may know a lot, but things do change and technologies change. But, you know, in 20 years of looking at dryers, has the technology really changed? Well, I think a lot of manufacturers would say it has, but I don't, and they may have some strategic advantage about, their dryer versus somebody else's, but the problems are still the same. And we haven't combated those problems. So I know is Lee, is part of the focus related to firefighters?
It's for everybody, right? So, I think you've mentioned it before that, the first line of defense is gonna be the farmer, because if you shut the grain dryer off, and you create those air pockets, you're gonna have a bigger concern before the fire department gets there. So it's the focus is for everybody, but we do have a couple of firefighters on as well as farmers.
Yeah, so I think, the firefighter, from the firefighter aspect, I mean, I think they need to just kind of change how they're looking at this, because what you have in front of you is a chimney. And even if it's a house style dryer, like, there's so many different styles of dryers out there, but the cascading type of dryer that exists out there that I haven't seen in Ohio, but I believe that they're everywhere, Grain Handler and others. Those dryers also have fires. A lot of those fires are slightly different than what I've talked about in the world of the tower dryer. Those particular fires have a metering roll on the bottom. It's an aluminum paddle, if you will. And I just see all kinds of crazy things happening in those, where somebody dropped a screwdriver in, and a screwdriver took out a section of the metering roll. So the rest of the metering roll system didn't work. Well, they didn't know because they weren't there. They think it's still working. They walk up to the end where the chain is, and it's still turning like normal. And everything looks good. And then they don't discover until they drain all the grain out and go, there's a screwdriver stuck in my metering roll. Or so now all of a sudden that grain in those series of columns is stagnant. It's not moving. It's overheating. And those are hard fires to get away from too. But form material is an issue in dryers. And from the firefighter perspective, again, this is a complex area. And as much as I'd like to say I'm an expert at putting out fires, I'm going to tell you right now that I have more time and more experience starting fires, because that's what I study. I study how a fire starts. But in the scenario of the grain dryer or an explosion internally to a large holding facility, a grain, a terminal or something, that's an area where I do have a fair amount of expertise. Has anybody responded to any new technologies, or were they just kind of curious if they exist?
I think they're just curious. So,
Okay.
yeah, farmers, because we're in that scenario where a lot of people are increasing acreage, but not increasing labor because we're doing more with less equipment. So time is valuable. So some of those automated systems would be useful as farms increase capacity too.
Yeah. So, just as a caution to firefighters, I think there's other types of fires that they get called, and they're just kind of scratching their head on what to do. Now, I don't mean that in a bad way. I just mean that, the average firefighter who's not familiar with the grain industry really is only going to fall back on what he knows. We have muscle memory based on things we know. And if we don't know anything about it or know very little about it, then we have issues related to that, because now we're kind of making assumptions that may or may not have a valid place in trying to put that fire out. Again, firefighters love to put water on fires. And when you have a bin fire, what do? They want to put water on that fire, but I've never seen a bin fire put out with water, unless it's extremely, extremely small. I have seen bin fires put out in other ways. So I don't know if any people, or if there are any farmers on this site right now that have an experience where they have physically put out a fire with water in a bin. I think there's some discussion that needs to happen there, Because if you think about a bin fire, and I don't believe that the farmer site bins are as big as some of the large bins that I'm used to, but I see bin fires in 650,000 bushel, million bushel or larger, sometimes 500,000 bushel, sometimes 250,000 bushel. The small bins are much easier to deal with, but the putting water in a bin, where's that water going to go? If you look into the top of the bin and you see a hot spot or a glow and you put that glow out, you don't know where the fire is after that. So a thermal imaging camera, I've had very good luck at determining where those hot spots are in those bins. And all I ever try and do when I deal with a bin fire is I'll just try and quench that area just a little bit. I don't want to use too much water. Just give me time to solve this problem, this puzzle, in a whole different way. And the way that I solve it is I drain that bin. And, you know, if you had what's a typical size of a bin on a farm site? Do they have
Andrew,
250s?
30 to 40,000.
Yeah,
Some
so
of the
those
bigger
are just small, you know, and, you know, if you unload by a side tap, that works, but it also causes another problem. If you unload to some level on a side tap and you put side pressures in a method that bin is not capable of handling, you're going to have bin collapse or bin damage. So the way that I mostly deal with bin fires is I'll side tap them down evenly if I have that option. I'll utilize just a little bit of water in specific spots, but I'm not condoning that a firefighter should go to the top of that bin, because I've seen other things. You know, if the whole top of the bin's burning or there's a really big area and you put water in there, water has a steam conversion that's very aggressive and it'll blow you right off the top of that. That's a bad day. And I've seen many firefighters get blown right off the top of bins because they felt that they could just add water to a roaring fire inside a bin, and it turns out to be a really bad day. I mean, for everybody, the farmer too, especially if they're local community, they probably know that guy. So what I like to do is, and what I'm always concerned about is an explosion inside a bin fire. But at a 30 or 40, there's not, you know, you can drain those bins relatively quickly by side draw, and then maybe you need to punch a hole into the bin, which people may not like that idea, but that is the easiest way to get that to happen. Shut the fans off. Try not to draw air in there. Don't put it into a leg. If you have an auger, you can auger it out of the bin onto the ground. That sometimes is successful. If you know, at that point, you're trying to save that fire from going to other places and damaging other equipment. I've seen a lot of fires in bins end up creeping into or extending up into a leg system or a conveyor system, and that tends to have another issue. So one possible way to stop that fire from creeping up into somewhere else is if they have a gate on the top of that bin, which at a 30 or 40, I doubt they have a gate. You know, I just flood that spout with wet grain and let it sit there. And if you think it's going to go up that spout and get into the leg, you want to, you know, be able to continue working if you can, and not damage all your equipment, because that'll just put them down for probably the rest of the season most often. So, so to me, the issue with bin fires is to get the grain out of the bin, only utilize a small amount of water just to quench if it's safe. If the fire is too big and too roaring, don't sit there and start to put water in there, because the steam conversion which is an explosion, will just blow you right off the top. I've seen it lift the entire top of a round bin. And so tying a hose to the top, sticking into the bin, a lot of guys say, hey, we'll just do that. And you're not defeating the issue. You're just adding some water to it. And if you can't get the water to where you need it, which is almost impossible in a bin fire, then you're not going to put that bin out. So the best way to go after it is to drain that bin. I think as the farmers in your communities grow and want to capitalize on more profits or retain grain so they can sell at a time when it's more conducive to the market, they're going to get bigger and bigger bins. And that's when you start having more and more problems, because sometimes I see people holding grain for what? A whole year. And I don't know that the farmer that I was at does that, but it's possible that there are many sites that do that. Do you see that happening?
Yeah, it's a pretty common occurrence, holding on to corn and beans to take advantage of the market. So I wouldn't say it's uncommon. I would say it's more common than not.
So, and I don't know if they can hold 250,000 bushel or 500,000 bushel on a site. And, if they have a series of 60,000 bushel bins, that's a whole lot of bins. But maybe that's what they do. I do believe that the gentleman that I was at his farm, his were around that 60,000.
Yeah. So, and I think that was a local co-op grain collection area as well. So other than our co-ops, I think, and our larger farms, I think that 30 to 40, 50,000 bins, there are a couple 60,000s, but it's not, we don't have the 1,000,000 bushel capabilities in one bin up here.
Yeah. So that's kind of like job security. When you go there, you're going to be working there for a while.
So Peter, we're coming up on an hour, and I know you're very busy. I want to be, we'll talk all day if you have time, but I just want you to be respectful. If there are any other questions that are coming in, if you want to jump those in the chat box or unmute, because I know Peter is a very busy and in-demand guy. So if you have any questions, feel free to jump in.
One other thing, and we haven't talked about this at all, is explosions. And, in farm sites, I don't think you guys are seeing as many explosions, but in the grain terminals and the concrete storage facilities that I work on, there can be a very devastating thing. So that maybe for a future conversation, that would be an area to talk about a little bit. The biggest thing from the firefighter aspect that I deal with is they don't know what to do. And that's not demeaning to them, because, they're just, most of the firefighters are just not simply familiar with the farming communities. But in these smaller areas, where it is only a farming community, the nice thing about your area is you've got people that are interested, firefighters that are interested, farmer firefighters that are interested and want to know more about it. And the biggest thing I believe you can do is figure out a way to keep that wet grain flowing into that dryer and let the hot grain flow out. And that will put your fires, the majority of your fires, out. The other thing that I think is a very responsive method to put the fires out is have some sort of internal water line that you can turn on and just hammer the inside of that dryer with some water. You got to remember that once water goes to steam, the conversion ratio is quite large. So you want to start that out slow and start cooling it down. That is my biggest concern with putting water inside. We talk about conversion ratios of things, so that's got a lot of potential right there. Steam does. So you got to be very sensitive to that. and don't think it's the fail safe, because it isn't. But, so I don't know if that's helpful. I don't see any other questions coming in unless you have some.
No, I mean, I can
Peter?
chat your ear off all day, but I think
Wait.
Andrew has some details about your trip up here.
Okay, Andrew does. Hi, Andrew.
Oh, I was going to ask another question. Can you hear me all right?
Oh, yeah.
I can hear you just fine.
I just wanted to, I know you covered it a little bit, different scenarios and stuff, but I wanted to see if you could speak on maybe some best practices for prevention. You know, we talked about hardware getting stuck in the dryer that caused issues, and other things that cause issues. Do you have any best practices or suggestions in your years of looking at these issues and seeing what caused them, for our farmers to be aware of, so that they can, you know, stop the problem before it happens?
So what I see, Andrew, is, and we talked a little bit about it, but I'm just going to make some lists as we talk here. One of them is even moisture, because, you know, if you send in even moisture and you have your dryer set up, even theoretically in a manual mode, it should work just fine. But I don't believe that the moisture is something that they can easily accommodate because of the issues. You know, some fields are wetter, some fields are drier. They only have one wet bin, and so they're putting anything that they think needs to be dried in one bin. And you know, they may have 1,000 bushel of 17%, and if their wet bins are small, it's not a big deal. But I do see bigger and bigger bins that they're using for wet bins because they don't want to run out. So that's one thing I believe that is a preventative method. The cleaner you can keep that grain that's going into the wet bin, the better you can set up your combine so you don't get the leafy, broady material. I think is a very a good process to stand by. I really believe, Andrew, that the best thing they can do is monitor these while they're using them. And that is a very good preventative way. You know, what happens when we monitor something, we get to understand it very well. And we see spikes in temperature, something that's not normal. That we can, you know, the outer ring temperature sensors will give us some clues of what's happening inside that dryer if we know how to read them. So I love real-time information on those sensors that a farmer can sit there and look at while they're drinking coffee and thinking about getting into the field, or having somebody look at, just monitor this. And if they will tell you something. And if you see spikes in those temperatures that are below the shutdown temperature, which is often, I don't know what your rings are set at out there, maybe 220 degrees, 230 degrees. And people think, well, corn doesn't, you know, corn can't ignite it at that temperature. Well, what happens is you may be getting ready or close to an area where the corn can take on a life of its own and start a runaway deal. So monitoring those things, I think, are important. But even moisture, the you know, ensuring that your grain flow is clean as possible, doesn't have a lot of foreign material, particularly the broad, you know, the leafy material or stocky material that really creates a lot of havoc in these dryers. And then just monitoring that dryer is, in my opinion, the biggest thing that these farmers can do.
Thank you, Peter. And speaking of your visit later in the year, I know it's coming up here shortly. I don't have specifics on the date from the Farm Bureau, but I know you're working with our local Farm Bureau on coming out for an in-person presentation. So we look forward to seeing you then. And everybody on the call, I will make sure to send you that information as soon as it's readily available. And if you're a member of Farm Bureau, you should be getting that information as well.
Yeah, okay. Well, I've been in touch with, I think it's Mandy, is it not?
Yep.
Yeah, and so, and she's asking me to come out and talk to you guys. So, the one thing about me is I like questions. So come with questions, and I don't mind somebody says, oh, that doesn't work. Let's talk about that. And so if they've had different experiences, it helps me learn more. And hopefully it'll help them learn more. I will not get offended by people saying, well, that's BS, that isn't going to work, and so there's a discussion that can come out of that that's good. So please, please tell people to speak up and ask questions, and no question is a bad question unless you don't ask. So.
All right, Peter. Well, I appreciate your time and being with us today. Great information. I learned a lot. I hope our participants did as well. And I'm looking forward to buying you a cup of coffee or beer if you're here in the evening when you're actually up here in person. So
There you go.
thank you, Peter. I'll stop recording here and